In this video, we're going to look at solving linear systems by graphing. And when we talk about a system, we're looking at two linear equations where the solution is an ordered pair that satisfies each equation. So we will kind of go into systems with more than two, but we're going to start with two, and we're only going to focus on graphing in this video. So when we look at a system, it means for this case we've got two linear equations. So in this set of pictures here, you can see the three different scenarios we would be dealing with. So the first one would be where the two lines actually meet at one point. So this point right here is the one solution. All right. Some of our examples, we might have infinitely many solutions. And when we have infinitely many solutions, it's because it's actually the same line that's overlapping itself. And then we would say no solution if the lines are parallel, which would mean they never cross. Now, remember, one of the things we've already looked at is that parallel lines are going to have equal slopes. So when the lines have equal slopes, that's how we know that there is no solution. Okay? Now, over here in infinitely many, they're actually also going to have equal slopes, but they're actually here going to be the exact same line. Okay, and it's not letting me write nicely. Okay, so let's go ahead and just look at some examples. So if I go ahead and I want to find the x and y intercepts, or we're going to graph these however we want to, and even though this is systems are not going to be on your Unit 2 test, graphing lines is a really great review concept. So since this one is written in standard form, I'm going to graph it by using my intercepts. So using my intercepts means I'm going to find the x-intercept, and when I want to find an x-intercept, that actually means I'm going to ignore the y, or let y equal 0. So 2x equals 4. So x equals 2. So my x-intercept here is going to be at 2, 0. And then again, for this line, because we do need 2 points to graph a line, I'm going to find the y-intercept by setting x equal to 0. So I'm going to have negative y equals 4. So y equals negative 4. So I get the point 0, negative 4. So when I go ahead and I look at this line here, we're going to have a x-intercept at 2, 0 and a y-intercept at 0, negative 4, and that would be my line. Now if I go and I look at the second equation, we have an x minus 2y. So I would say x, and this is now for the second equation, equals a negative 1, because if I set y equal to 0, it's just that term is going to go away. So I'm going to have a negative 1, 0. And then if I let the x equal 0, I'm going to have a negative 2y equals negative 1. So y is 1/2. And that makes the point 0, 1/2. So if I come over to my graph, I have my one point, my one intercept at 0, negative 1, or sorry, negative 1, 0. And I have my other intercept at 0, 1/2. So when I graph these lines, this I can clearly see the two lines intersect at one point. That is the solution. So the solution to this system is the point 1, 2, 3, 2. Now on your quiz on chapter 3, do not turn it in until you've just double checked that those are the correct answers. And the way we do that is by plugging them in and making sure they work. So if we go ahead and I type in a 2 times 3 minus, and then the y value is a 2. If I have the right answer, I should get 4, which works. A 3 minus 2 times 2 should equal negative 1, and it works. So that tells me those are the solutions. And then I do want you guys to try and do this one and find the solution for me. Okay, So the one little trick I'll show you here with this line is x plus 2y equals 0. If you solve for the x and y intercept, you're going to find that they're both 0, 0. Well, 0, 0 is not good enough to plot a line because you need two different points. So this is one you would actually have to solve by rewriting it in slope-intercept form. So we would say a 2y equals a negative x. And when I divide by 2, that actually means y is a negative 1/2 x, which means slope is negative 1/2, and the y-intercept is 0, which we already found. But then for my line, what I would do is I would start at 0, and then I would count down 1 over 2, or up 1 and to the left 2. But please make sure, go ahead and graph this other line and then find where the two lines cross. All right, so just following along the same track with the ones we were just doing, the only thing I would say here, and I do want you to also try these on your own too, is this right here is in slope-intercept form. So if I was going to graph y equals a 2x minus 1, we would stop at a negative 1 and go up 2 over 1. And then we would go up 2 over 1. And so that's how we're going to graph when we're in slope-intercept form. All right, so if I wanted to just graph this one, since it's in standard form, I prefer to just graph using intercepts instead of taking the time to solve it for the y. So I would say negative 6x equals negative 3. So x is a 1/2. And then I would say a 3y equals negative 3. So y equals negative 1. And if you look at what happens here, if I have an intercept at 1/2, 0, and I have an intercept at 0, negative 1, that's actually the exact same line we just graphed. So those lines are overlapping. That's infinite. Okay, so this is what infinite solutions look like. Okay. Now, over here, if I go ahead and I look at this first equation, I would have a 4x minus 3 equals a y. So I would start at the negative 3 and count up 4 over 1. If I go ahead, and again, since this one you could solve for y or do the intercepts, I would see a negative 8x equals an 8, so x is a negative 1. And I would see a 2y equals an 8, so y equals 4. So I would have my two intercepts, one at 4 and one at negative 1. And when I go ahead and I draw that graph, you notice they're parallel. Now, just to make one last point in this example, if I did put 8x, negative 8x plus 2y equals 8 in intercept form, I would say 2y equals an 8x plus 8. So if I divide by a 2, divide by a 2, divide by a 2, we would have a 4x plus 4. So notice these equal slopes with different y-intercepts. That's how we could also tell that there was going to be no solution, because we're looking at parallel lines. All right. So if we just mix in an absolute value example, again, this 3.1, even though it's not officially on your test, it's very helpful for Unit 2, because you are going to have to graph these concepts on Unit 2. So if I went ahead and I looked at this graph, I would say I have a vertex at 2, negative 1, and I have a vertex for this one at 2, negative 1. So if I go ahead, I'm going to graph this one first, 2, negative 1. But the top equation has a slope of positive 3. So I would count up 1, 2, 3 over 1, 1, 2, 3 over 1. And then I would do the same thing. 1, 2, 3 over 1 this way. 1, 2, 3 over 1 this way. So if I went ahead and I drew this in, I would have that absolute value graph. And then if I go ahead and I graph the bottom equation, I have same vertex. So that right away shows me my point of intersection. But then I'm counting down 3 over 1 and down 3 over 1. So when we want to solve a system of equations, you're looking for the point of intersection. So my solution to this is at 2, -1. All right. And last example, systems don't have to have the same type of equation. So we can have a system that has an absolute value and a system that has a line. So if I go ahead and I look at this absolute value, I would have a -2, 2 as my vertex. So -2, +2, and then down 1 over 2, down 1 over 2. And since I'm going to be looking for a point of intersection, it never hurts to put a couple extra good points there. So that's my absolute value graph. And if I go ahead and I graph this one, again, since it's in standard form, I want to use my intercepts. So I would say my x-intercept is -6, 0, and my y-intercept is 0, 1. So 0, 1. And then if I graph -6, 0, 1, 2, 3, 4, 5, 6, right there, since we kind of graph some extra points there, I can see where the two are going to cross. And so that's my line. So this system actually has two solutions. We have a solution at -6, 0 and a solution at 0, 1. And that's my answer. All right. So we're going to go ahead and just if we want to look at one more example, this is an example of linear regression with a system. I'm not going to do this one for you, but I do want you to try it. I want you to get a line of best fit using this as L1 and San Diego as L2. And I want you to write the line of best fit. And then I want you to change L2 with Detroit data, and I want you to write an equation of a line for the Detroit data. And then we're going to go ahead and graph the two lines using y1 and y2 in our calculator to look for the point of intersection. But we will start here, but I do want you guys to practice your regression equations. Again, that's going to be a helpful concept on the Unit 2 test.